Let's talk about drawing alkanes. So, as a student, it's important that you know the different ways that you can draw the structures for your alkanes, right? Your alkanes can either be presented as line angle formulas or bond line, or it could be a Lewis structure. Whichever one, as a student, you need to be able to identify every single structural format, right? Because your exam could come in any type. All right, here we go. We're going to start with bond line, which is also known as line angle formula or line angle structure. We're going to look at how to draw alkanes as a bond line or line angle structure, right? Now, it's in the name, bond or line. Literally, when you draw alkanes using line angle formulas, you are literally connecting bonds. That's a bond, right? And you connect your bonds in a zigzag format. This is literally what your line angle look like. You're connecting bonds, right? Now the important thing is, I don't like how this one looks. The important thing is, what does the structure, the lines mean? And we're going to talk about it, right? So bond, bond, bond. That's it. So here's the key now though, right? At the end of every line is a carbon. Where I put a dot is where we have a carbon. Let's use another color. At the end of every line, we have a carbon. Where two bonds meet, see the two bonds meet right here? We have a carbon. So I have a carbon here. These two bonds meet right here. I have a carbon here, and there's a carbon here. Now remember, right, that we're drawing alkanes, which only consist of carbons and hydrogens, which brings me to an important point. In a line angle or bond angle, whichever one you want to use, hydrogens are not shown. They're not shown, but here's the key. You can tell how many hydrogens are on each one of these carbons, right? It's easy to tell, and I'm about to teach you how to do that. Remember, from Gen Chem or earlier in this module on my channel, a carbon, when it's neutral, it has four bonds, right? Now, we're looking at alkanes that contains only hydrogens and carbons, which means on each of these carbons, there's some hydrogens that are not shown. But guess what I know? I know that the carbon needs four bonds. So let's talk about it. Let's take this carbon, for example. I'm going to number them 1, 2, 3 so we can talk. On carbon 1 here, right, we only see one bond, which I'm highlighting in blue here. We only see one bond drawn to that carbon, which means that I have one bond, but three is missing. The three missing bonds are your hydrogens. Let's go to 2. Carbon 2, this bond and this bond is drawn towards 2. So I see this bond and this bond drawn towards 2, right? So it means I see two bonds, which means 2 is missing. The 2 that is missing are your hydrogens. So on carbon 2, I have 2 hydrogens. On carbon 3, on carbon 1, I have 3 hydrogens. Let's look at carbon number 3. Go to 3. I have this bond and I have this bond. So carbon 3, I see 2 bonds. So what's missed? The other 2 bonds that is missing is my 2 hydrogens. If we look at carbon number 7, right? 3 bonds are missing. This is the only bond I see. So you look for the bond you see. Look for the bond that you see. If you only see 1, it means 3 is missing because you need a total of 4, right? The bonds that are missing, so let's write that down. Missing bonds are, or let's put equal. I think I like equal. The missing bonds are equal to the number of hydrogens. Let's look at another one. Something a little bit different now. What if you had something like this? Right? What if you had something like this, and I still don't like how this looks. Let's redraw this. Let's go. So let's this. We have that. We have a bond going that way, bond going that way, bond here. I prefer this. Okay, so here we go. Let's talk about the carbons in here, right? So remember, at the end of every bond is a carbon, right? Where the lines meet, or where your bond meets, is a carbon. So where these three meet, this is also a carbon. Now let's talk about the number of hydrogens on here. Here, carbon 1, I only see one bond. I only see one bond, which means three are missing. The three missing ones are my hydrogen. On carbon number 2, I see one, two, three bonds, right? You still have to count this one because it is on it. So one, one, two, three bonds, right? So which means only one hydrogen is missing right here. Let us go to carbon number 7. Carbon 7, I only see one bond to 7, which means three bonds are missing, which means I have three hydrogens on carbon number 7. It's important that you're able to see these hydrogens, especially when you start writing reactions and you need to know where to add what, right? Let's go to carbon number 3. Carbon 3 is here. I see one, two, three, four bonds. Guess what? There's zero hydrogens on carbon number 3 because it has four bonds. There's nothing missing, right? I'm going to do one last one. 5. 5, you see your one bond that 5 has, which means that there are three missing bonds, which are your three hydrogens, right? So this carbon, as we established, only has one hydrogen. And that's how you handle your line formulas. Just remember, at the end of each line, there's a carbon where the two lines meet or where the two bonds bond. There is a carbon, carbon, carbon. So if I drew this, there's a carbon here, there's a carbon here. Please remember